I'd like to welcome you to Friend MTS at the NAB Show Express. I'm Alan Ogilvie, I'm the lead product manager here. We are a content protection organization, so we help you protect your content, your investment in that material, and your revenues from that material. And today specifically I wanted to talk to you about the streaming content gaps. This is going to be about 15 to 20 minutes. It's going to be quite high level, so I'm going to give you some further reading if you're interested in more. So without further ado, let's get on with it. So firstly, to say that the Friend MTS is the leader in anti-piracy technology. We're privately owned and exclusively focused on video piracy. We have an Emmy Award-winning proprietary and patented technology, and we offer scalable and fast takedown of content pirates. What we'll cover today is we're going to generally talk about piracy within streaming services. We're going to talk about digital rights management and how that impacts. We're going to talk about a couple of different types of watermarking that are relevant to the streaming media side. We're going to look at monitoring and detection, and then we're going to have a brief discussion about DRM and watermarking together. So first, it's worth saying, pirates will always choose the cheapest, the easiest to capture, and the most scalable service to source from. That means nowadays more and more pirates are sourcing from legitimate streaming media services. That's because more and more premium content is exclusively available on those services. So it's really important for us to help you protect your investment and revenues. The piracy landscape, well, it's a huge business. The US economy, for example, suffers at least $29.2 billion in revenue losses each year. It's big business. Don't just think of it as small-scale piracy at all. Even pirate wholesalers who supply other pirates. It has high production values and good quality video in the pirate services, and they often make consumers think that they could be legitimate. Also, there's an appeal to some where pirate service offers hundreds of thousands of video sources for one low price. Look at the fragmentation of legitimate streaming services and consider the impact on consumers' expectations. Digital rights management is a set of technologies used in video OTT streaming services to secure the delivery of media on the internet. But we need to remember that the majority of the DRM widely deployed is only effective up to the point of consumption. So let's see what I mean here. Let's take, for example, a typical legitimate service, streaming service. We have on the left, we have our pre-distribution, so acquisition of material, then we have encoding and packaging, through to content distribution, maybe the CDN, we have origin and edge here, then into the player on the device. And then we have the player screen. This is the distribution chain of our material created, and the DRM protects the delivery of the media between the red lines where it says DRM protection along the bottom. So once the device presents to the consumer, the eye, shown here, via its display, the blue pane of glass, shown here also, the DRM plays no part in providing any additional protection. Even if I were to use a digital video output from the device like HDMI, even though there are policies agreed between the DRM provider and the device manufacturers, it could be asking the device to not output the material, perhaps insisting on something like HDCP, high bandwidth digital content protection. This is inherently broken these days and just can't be trusted. You can buy simple devices that allow grabbing material which are using HDCP. So DRM only protects the media delivery to the device. Is there anything we could apply to the video itself which could help us protect the material further in the post-consumer world? Well, yes, because we could embed a watermark in the video itself. Watermark is just a general term used in these technologies to describe an imperceptible visual identifier within the visual field. Watermark is sometimes used to talk about very visible visual identifiers, but we're not talking about those sort of techniques here. These imperceptible visual identifiers could be applied at the origin of the video, at the distribution head end, at the CDN, or within the playback device itself. If you remember our previous diagram, the addition of the watermark appears here. So we have our same setup of delivery, and then we have the watermark has made it through onto the video and is presented in the player. It's also visible on the device's screen, the blue pane of glass. and if you're using HDMI output, it would also appear there too. If a viewer were to grab the video and use it as a source for piracy, for instance, then this would retain the watermark itself. Now, why is this important? What does the watermark mean, and how can it help us? Well, depending on the watermarking technology, the watermark could contain generic information about where it came from, but it could also contain information on the device's IP address, the session details of the player, the identifier of the subscriber, or pretty much anything else that's useful to know. This is called the Watermarks Payload. If a video is found from a pirated source and it is identified to contain a watermark, then we can extract this data from it and provide that information to the legitimate streaming provider who can use that data to take action. I'll leave the details on what they can do for another time. Now let's look at two common watermarking technologies relevant to streaming media. First, we have a technique described as AB variant watermarking. The same video is processed into two variants, one containing a watermark that distinguishes an A and the other a B. If you like to think of this as binary zeros and ones, that's okay. Basically, just two different watermarks can be used in a sequence that uniquely identifies the subscriber. The payload of this watermark is basic. It can only contain generic information about where it was distributed from. It's the unique order of the segments that would allow a specific subscriber to be identified. You can consider here that the payload, for instance, uniquely identifies the subscriber is spread out across the timeline of the video. Also, I like to think of this as old school Morse code. And if that makes you think about the time it takes to convert incoming dots and dashes into words, then you're not far wrong with the uniquely watermarked stream. In order to deliver this, you obviously need to pre-prepare the video segments with two variants. That means you'll need extra resources during encoding and extra storage space. Then multiply that by your adaptive bitrate ladders. Our second watermarking technology makes use of the client device, where the watermark is composited with the video. We describe this as client composited. That means your video encode remains the same, with the same resources required to deliver as usual, no extra storage in your delivery chain. But also, this watermark is always present. Unlike AB variant, which requires a much longer time period to uniquely identify a subscriber, client composited watermarking can be extracted from much shorter captures of suspected pirated material. Client composited, by the nature of being added on the client device your subscriber is using, allows you to include information such as the client IP address, the subscriber identifier, anything to identify a subscriber. And to do that, unlike AB variant, it isn't spread out across the timeline, so it's always on. If you think of the client composited a bit like a QR code or a barcode or something similar, it's not far wrong. The imperceptible watermark would look like seemingly random patterns if you were to force it to be visible. So, how do these two stack up? So, I've picked a few criteria I'm going to use to compare the two technologies. Optimized for. What is the watermark technology really optimized for? Does it work well for both live streaming and low latency requirements, or video on demand services, or both? The extraction performance. This is about how fast it is to extract the payload of the watermark. How quickly can we identify the source of piracy, for example? Robustness and attack vulnerability. This is a very quick summary of whether the fundamental building blocks of each watermarking technology are susceptible to being broken. I'll give you more details on this at the end so you can find out more. Cost implications. The ever important cost. To implement the watermarking technique will mean what to your costs? Multi-CDN ready. This is becoming increasingly important as many streaming media or OTT services start to use multiple CDN services to deliver their material. Does the watermarking technology work smoothly with this? Deployment to date. In the assessment of our investigations team, are we seeing more or less of a particular technology? That can sometimes help establish what you should be using. And finally, the primary applications. A very high level note on what the watermarking technology is primarily used for. So, first let's look at AB variant. Optimized for, well, it's on-demand content really. The processing to create the variants and deliver them would have an impact on low latency live streaming, so whilst technically possible, it's not optimal. Extraction performance is slow. Think of the time it takes to uniquely identify the subscriber. Think about when you begin your capture of the suspected pirate service, when the payload of the watermark, the unique sequence, can be understood in its entirety. Think about error checking, padding, boundary identifying. It all takes time. Robustness and attack vulnerability. Well, we've seen the real-world attacks on AB variant. It's easily broken. Whether you're doing your segment switching at the CDN edge, so edge switched, or using the streaming manifest to do it, that's manifest switched. And in the link I'll give you later, you'll be able to look at the attacks in more detail. Also, once it's broken, it's done. It's not flexible to adapt to the pirates. Cost implications. Significant. As mentioned, you have the increase in code and package resources needed, the increased storage costs across your delivery infrastructure, not just origin, but at edge too. So those changes are going to cost you. Multi-CDN ready? No. I've said this here because it wasn't really designed with multi-CDN in mind. It could be adapted, but the complexity would increase, and why bother since it's easily broken. Deployments to date, least used. Really, there's a lot of talk about it, but the problem is that it's easily broken, so it's not really widely deployed. Primary applications, streaming media only. So I mentioned that I'd flag up whether the technology would be used for traditional broadcast platforms too, so you can get an idea of the investment you need to make. With AB variant, you'd need to employ another technique for watermarking on your other platforms. So let's take a look at client composited. It's optimized for, well, because the watermark is applied in the client device, it doesn't impact on live streaming latency, and it works for on-demand content too, so no problem, it's flexible. Extraction performance, fast. Because the payload of the watermark, the bit that can identify your source, your subscriber, is throughout the video, we don't have so much messing about as we do for AB variant to find the start of the Morse code, if you like, and to wait until we capture enough to get to the end. With client composited, it's quick to get the info you need to take action. Robustness and attack vulnerability. There are some attack vectors on this which can be mitigated, but luckily it's adaptable, so every time the pirates think they've got a good idea to avoid it, it adapts. So it's considered secure, certainly more so than AB variant. Both watermarking techniques require you to increase the robustness of your client playback environment. Cost implications. Well, compared with what it's going to cost you to implement AB variant watermarking, you're looking at no delivery infrastructure or storage cost increases, so it's low cost. Multi-CDN ready? Yes. By the nature of being embedded on the client device and not part of your delivery chain with multiple CDNs, then it's ready for multi-CDN in your architecture. No problem. Deployments to date. Most widely used, we know of several massive organizations with large subscriber bases which employ client composited, and more about that in a moment. Primary applications, client composited can be handled on both streaming media solutions and other broadcast platforms, so it's flexible and works across multiple devices, whether internet connected or otherwise. So, really, the winner is client composited. Now, I've not mentioned what our watermarking technology is, so you'll be glad to see that Friend MTS uses client composited watermarking techniques, and we call it our Advanced Subscriber Identification, or ACID. We have a suite of different options depending on the primary application needed. We and others, including the Emmy Awards and other major film studios, believe that our client composited watermarking technology is fit for purpose, robust and cost effective. The same technology is available for OTT streaming services as well as many other services like direct-to-consumer satellite. It works with live and on-demand content. It's used by our customers to allow detection of piracy, deter piracy, and ultimately disable the source of the piracy, as a payload in the watermark can be used to identify the source that our customer can then shut down. The graphs shown here show a large customer who had an OTT piracy issue, shown on the left, and then a week later, after turning on ACID on their OTT service, they saw the source of piracy fall from their OTT service on the right. Earlier I mentioned that client composited watermarking technique was the most widely used when we looked at the deployments to date evaluation metric. And that claim is based on the number of end users that our customers deploy ACID to. It is the most widely deployed solution. But one thing that I've not mentioned so far, so you have your DRM for delivery, you've added your ACID watermark, but your content can still be captured and used by a pirate, but not for long. That's where our piracy detection on global monitoring comes in. You've got to monitor for your material cropping up on pirate services. If you implement our ACID watermarking on your streaming services, then it will have the payload in there that we can extract and tell you the information about the source, letting you take action and stop piracy at its source. In order to monitor, we also take fingerprints of your source material so we can compare quickly your source with found suspect material on pirate services. We monitor on pirate websites, streaming devices such as Kodi boxes and apps. We're always finding new ones and we're updating when things change. Pirates will try to avoid detection by tampering with watermarks, but our technology allows you to be confident that the pirates will not succeed. So it's important that you implement a watermarking solution that's able to survive these attacks. Our ACID watermarking is robust and can adapt to pirate activity. Before I leave you with some further reading on watermarking in our services, I wanted to take a moment to talk about the importance of digital rights management and watermarking working hand in hand. It's important that your streaming service's DRM solution is implemented to be as secure as possible, following the guidelines by the DRM provider and penetration tested where possible. Our team comes across situations where streams from legitimate services have been liberated, shall we say, and reused on a pirate service. So you are paying to distribute to the pirate's users and not your subscribers. Our integration engineers will help you to understand the end-to-end nature of content protection and the importance of every step. Although we don't provide DRM solutions ourselves, we have a number of partners that we rely on for advice and intelligence, and they rely on us for the same. We collaborate to fight piracy. So I think that's enough from me. If you want to ask me anything, please do. My details are here so you can get in touch. I've also provided you one further reading resource that will give you more info about what I've just been talking about. Go to our blog and our website. The QR code is shown here to get you there quickly, and you'll find our recent articles entitled Beyond DRM. It's a series that we began on the 2nd of April this year and with our friends over at Piracy Monitor. Part 2 is already available. Third and final part will be out soon, hopefully by the time you've watched this video. In the third part, we'll be publishing access to a PDF which provides a summary of these watermarking techniques, and you'll have the opportunity to sign up for the white paper, which will cover in more detail than I was able to talk about here. Thank you. Goodbye.